Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over how to solve differential equations, and this will be problem number 1 of our multi-problem series. Alright, the instructions for the problem are as follows. We're to find the particular solution to the differential equation. And the differential equation we're going to be working on today is dy dx equals 3 minus y cosine x. And this is with an initial condition of f of 0 equals 1. Okay? So this problem was taken from the 2014 AP Calculus free response question. This is problem number 6C. Okay, so let's go ahead and get started. The first thing we're going to do is we're going to separate the equation. Okay, so part 1 is to separate. Now, most of the differential equations problems that require solving for a particular solution on the AP exam requires separation of variables approach. There are many other ways you can solve differential equations, but this method is a high frequency method on the AP exam. Okay, so how do we separate? Now, what we're going to do is we're going to place the function of y and its differential dy. Let's place that on the left. And the function of x and its differential dx, we'll place that on the right. Okay? If you look at this problem, we have just two variables, y and x. The variables differ depending on the problem you do. Okay? Some AP FRQ questions, AP Calculus FRQ questions have different variables other than x and y. Okay, so you just go with whatever variable you have. So since I have dy on the numerator on the left, there's a hint that I want that differential and the function of the variable of that differential, namely f of y, in that side of the equation, and then dx goes on the other side. Alright, so let's go ahead and carry that step out. But before we do that, let me clearly identify what the function of y is for you. Okay, so the function of y in this problem is going to be 3 minus y, and the function of x is simply going to be cosine x. Sometimes one of the functions might just be 1. Okay, so depending on the problem. So this is f of y and this is f of x. So I basically want 3 minus y on the left side, and then we'll leave cosine x alone and just move dx to match up with it. Okay, now let's go ahead and do it. So we have dy dx equals 3 minus y cosine x. Now you can separate the variables in just one step, but I'm going to break it down into 2 steps so that I don't lose anyone. Okay, let's move dx to the right first. This can be accomplished by multiplying both sides by dx. Alright, so you see some cancellation action happening on the left. This divides out. So we're left with dy equals 3 minus y, our function of y, cosine x, our function of x, and its differential dx. Now we need this function of y on the left side. To achieve that, we will just simply divide both sides of the equation by 3 minus y, or alternatively, let me just multiply it by 1 over 3 minus y. Division or multiplying by its reciprocal is the same thing. Okay, so just do it like that. On the right side, these divide out, 3 minus y and 3 minus y. And then on the left side, I'm left with 1 over 3 minus y. Well, let me rewrite this in descending order of degrees. Okay, so negative y plus 3 dy equals cosine x dx. Okay, now what have we accomplished so far? If you notice, we have f of y and the y on the left and f of x and dx on the right. So what we've done so far is we've been able to successfully separate the equations. So it has been separated. Alrighty. Now the next step is to integrate both sides in order to get rid of the differentials. Okay. When we're looking for the particular solution, the goal is to get y isolated. Okay, because we're looking for that what y is equal to. So let's go ahead and indicate our next move. Step number 2, we are going to integrate both sides to get rid of the differentials dy and dx. Alright, now let's go ahead and do it. So we have 1 over negative y plus 3 dy equals cosine x dx. So we're going to integrate the left side of the equation and the right side of the equation. Alright, so I'm going to be using an integration shortcut. You can definitely use the u substitution method here, but I like to use a shortcut to integrate this integrand on the left side. So this is the main idea here. So I'd like you to recall the following fact. Now, if you are integrating the derivative of a function composed with a linear function, what do you think the answer is going to be here? If you integrate this, you're going to end up with the function of the linear function divided by m, okay, plus c. If you think about the chain rule, when you're differentiating a composite function, what you do is you differentiate the outer function and then you multiply by the derivative of the inner function. So what we're doing is we're basically going backwards. Okay, we're integrating the derivative of a composite function where the inner is a linear function. So when you carry out that, you have the function on the outside divided by the slope of the inner linear function. This shortcut works only when you have two functions. The outer is a obvious antiderivative and the inner must be a linear function. If it's not a linear function on the inside, this approach is completely wrong. Okay, so just keep track of what you're doing. If you don't like to use this shortcut, you can always use the u substitution method. And then you basically see what's going on here, because when you're looking for du, you just differentiate the inner function, and what you end up with when you differentiate the inner function, let's say this is u, when you differentiate that, you end up with m. Okay, and then you have, in order to get dx isolated, you have to divide both sides by m, and then you end up with du over m as the value of dx. So I'm just trying to save time. That's why I'm using this shortcut. Okay, so if you look at this function right here, this is a rational function composed with a linear function negative y plus 3. So 1 over u, what is the derivative of what function yields 1 over u? That's you can simply use the reversal of the differentiation rule. We know what the derivative of the natural logarithmic function is. It's 1 over u, right? So when I integrate the outer function here, I'm going to end up with the natural logarithm of, don't forget the absolute value of negative y plus 3, and I'll divide by the slope of this inner linear function, which is negative 1. And that's indicated earlier. If you don't like the shortcut, you can always use the use substitution method. You end up with the same thing. It just takes more steps. Okay? Now, what's the antiderivative of cosine? Cosine is a derivative, right? If you differentiate sine, you end up with cosine. There is no sign change when you differentiate sine, so when you're integrating its antiderivative, do not change the signs, okay? So this is just going to be sine x plus c. Let's rewrite this to make it pretty. So we're going to have negative natural logarithm of the absolute value of negative y plus 3 equals sine x plus c. Okay, let's call this equation number 1. Now, what is this? This is the general implicit solution. Let's put that side note. This is a general implicit solution. The problem doesn't ask us for a general solution, either explicit or implicit. It asks us for the particular solution. The difference is that for the particular solution, you don't have a c and you have y solved for explicitly. All right, so we still have some work to do. Okay, so in order to find the particular solution, the first part will involve determining what the value of c is. All right, so let's indicate what our next step is, part 3 of the whole problem solving process. We're to find c. Now, how do we find c? We're going to use the initial condition, okay? F of 0 equals 1. All right, so what does this initial condition tell us? You have an input of 0 and an output of 1. We can write this as a coordinate pair. The input, the independent variable, as the x coordinate, and the output, the dependent variable, as y. Okay, so this will be x, and this will be y. Now, what we're going to do to help us find the value of c is as follows. We're going to substitute 0 for x and 1 for y in equation 1, our general implicit solution. That will help us find c, okay? So this is our general implicit solution again, right here. So let's go ahead and carry out the substitution. If we do that, we'll have negative natural logarithm of the absolute value of negative 1 plus 3, so that's substituting 1 for y, equals sine of x 0 plus c. Now let's solve for c. On the left side, we have negative natural logarithm of the absolute value of 2 equals sine of 0. What is sine of 0? If you've forgotten, you can just draw your sine curve to refresh your memory. Or you can use a unit circle if you want. Okay, so we have our nice little sine curve here, like an S. So you remember, sine starts from the center, 0, 0. Sine of 0 is 0. Okay, so sine of 0 is 0, 0 plus c. So we can clearly see that our constant of integration in this problem is negative natural logarithm of the absolute value of 2 is just 2. Okay, bam. Okay, now that we know what c is, we're now going to go back to our general implicit solution, input this value, and solve for y. And that will be our answer. So part 4 is to substitute negative ln 2 for c in 1, equation 1 again, and solve for y. Okay, if we get y isolated, that is our particular solution. Now let's go back to our general implicit solution, negative natural logarithm of the absolute value of negative y plus 3 equals sine x. Now instead of plus c, we already know what plus c is. It's going to be the natural logarithm of 2. So plus minus makes a minus ln 2. Okay, so the goal here is to get y isolated. We're going to start by getting rid of the minus, the natural logarithm, and then with the absolute values, since we have a positive there, we just, this is quantity is going to be positive. We'll get rid of the 3 and then the negative in that order. Alrighty, so let's start by multiplying both sides of the equation by -1 to get rid of this minus in front here. Okay, if we do that, we'll have the natural logarithm of the absolute value of -y plus 3. Now, if you distribute this minus here, we can switch the order of this difference. So it's going to be ln 2 because negative times negative makes this positive. Positive times negative makes that negative sine x. Alright, now to get rid of natural logarithm, we use the inverse function, which is the exponential function. So we're going to take the natural exponent of both sides of the equation. So we'll have natural logarithm of -y plus 3, natural logarithm of 2 minus sine x. Okay, now on the left side, we can use the inverse property of logarithms to cancel these two out. So we'll have the absolute value of -y plus 3. And then here I can write this as e to the natural logarithm of 2 plus negative sine x. I'm expressing this in this format for a reason. You'll see it in a second. Okay. Now, this absolute value quantity could be positive or negative. So you have to take a look at your initial condition. Okay. So from the initial condition, we know that y of 0 is equal to 1. So that basically tells us that this quantity here is going to be positive. Okay? So negative y plus 3 is going to be positive, so it'll be negative y plus 3. In the AP exam, they always take the positive side of the solution. Okay, so that's a standard. Alright, so if we apply that fact here, we'll have negative y plus 3 equals, now using the product property of exponents, this can be written as e to the natural logarithm of 2 times e to the negative sine x. Now remember, what do you do when you multiply exponents of the same base? You add the powers, right? So we are reversing that rule. So you have the sum of the exponents. You can just write it as a product of the exponents with identical bases. Okay? So that's how I got this. Now we can implement the inverse property of logarithms here again. E and ln 2 can just cancel those two out. We have negative y plus 3 equals 2 e to the negative sine x. Two more steps. Let's get rid of 3 and then the negative. Okay, so if we subtract 3 from both sides, we'll have negative y equals 2 e to the negative sine x minus 3. Okay, and then if we multiply both sides of our equation by -1 to get y isolated, we'll have our final particular solution. Y equals, so we can reverse the order since we're multiplying by -1. Same procedure that we implemented earlier here. We're going to do the same thing here, and that will yield positive 3 minus 2 e to the negative sine x. So how do we know that this is the particular solution? This is the particular solution because y has been isolated and c has been solved for. Okay, you only have two variables in the particular solution, namely your dependent y and your independent variable x. And that's basically that. You can have a c there. Thank you so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your study of differential equations and the preparation for your AP Calculus exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, just place it in the comment section below and we'll be more than glad to assist you. Do not forget to subscribe to our channel for updates to other AP Calc tutorials. We always upload tutorials every week. So subscribe so you can get updated and notified of new uploads. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.